Good morning, students. So, in last class, we are discussing the major chapter in our physical chemistry is electrochemistry. So, already few topics we are completed under electrochemistry. Today, the major topic is problems and Nernst equation. In last class, we are already completed what is the formula of Nernst equation. If any one reaction is given, how to give the Nernst equation, and any cell is given, how to give the Nernst equation. The both things we are completed. So before going to this video, better to see once again that video, then again watch this video clearly. Let us start problems on Nernst equation. So the problem is this the following cell is represent. The cell is Mg solid plus 2Az plus gives us to Mg plus 2 plus 2Az. Here the concentration of the Az plus is 0.0001 molar. The concentration of Mg plus 2 is 0.0001 molar. Both concentrations are same. Okay. Now the question is represent a cell in which following reaction takes place. First you have to represent the cell. After representing the cell, even you have to calculate the EMF of the cell. Okay, that is the two problems are given in this equation, in this problem. So in last class already we are completed how to write the cell from equation. Okay, so let us start that. First we have to write the cell representation. While you are writing the cell representation, I already mentioned to you, first we have to write salt bridge. This is a salt bridge. Okay, after writing the salt bridge, then this is the one area left side, this is the right side. First I already mentioned to you, first in the left side we are completed Mg2 Mg plus 2. In the right side we have to complete Az2 Az plus. Why? Because salt bridge left side oxidation is occur, salt bridge right side reduction we have to show. That is a major concept here. While you writing the cell, you no need to mention the stoichiometric coefficient. See here Az stoichiometric coefficient is 2, but I am not mentioning the Az stoichiometric coefficient here. I hope you understand, guys. Okay, that is a major important. And after you should be write the concentration. Okay, so then let us go to the very important thing is EMF calculation. So how to calculate the EMF is by using Nernst equation. Okay, so for this reaction how to write the Nernst equation, let's go now. First is this is a Nernst equation that is called as E cell is equals to E naught cell minus 0.0591 divided by n log concentration of the products divided by concentration of the reactants. So let us see the once again that equation in this what the given the reaction in that product side is Mg plus 2 is present, reactant side is Az plus is present. Okay, this is a reactant side Az plus and this is a product side Mg plus 2. Okay, so that's why first we have to write the products divided by reactants, and here Mg stoichiometric coefficient is 1. Okay, but here Az stoichiometric coefficient is 2. See, while you're writing in the formula, we are not writing any solids. This is 2 we are not writing in this formula. That thing you have to remember. We are only writing the aqueous solutions. Means in the products, Mg plus 2 is the aqueous. In the reactant, Az plus is the aqueous. Okay. So that's why the formula will get like this. Once again, this is a log Mg plus 2 divided by Az plus. The stoichiometric coefficient of Az plus is 2. That's why I'm writing square. Okay. The stoichiometric coefficient of Mg plus 2 is only 1. That's why I need to show this 1 here. But here it is the presence of what? 1. Okay. So the next is, let us go. The major important thing is substituting the values. See, here is a very important thing is 2. What is meaning of 2 here? 2 indicate the number of electrons. Number of electrons. Okay. Here the 2 indicate the number of electrons. N indicate the number of electrons. Means Mg is losing the 2 electrons. Okay, na? Then that means that here number of electrons here involved is 2. And the problem, if you clearly observe the problem, they given inert cell already. That's why in the place of inert cell, I am substituting the what they given, that is 3.17 volts. And already I mentioned to you the concentration of Mg plus 2 they given 0.001. The concentration of Hg plus they given 0.001. So I hope it is a square. Okay, simplify this. Okay, you will get this one. I think you may get doubt how to simplify this one. I will explain now how to simplify this. See, first we have to simplify the log value, log side. What is, this we have to simplify first. Okay, after that you will get remaining properly. So how I am going to simplify? Let us look at log 0.0001. It indicates that 10 to the power of minus 4 divided by 10 to the power of minus 4 whole square, minus 4 whole square means 10 to the power of minus 4 whole square means 10 to the power of minus 8. 10 to the power of minus 8. Then cancel this. 10 to the power of 4, 10 to the power of minus 8 means still downside 10 to the power of minus 4 is remaining. Here 10 to the power of minus 4 is remaining, isn't it? Then you send the 10 to the power of minus 4 into up. This you can send into up. Then it is become 10 to the power of plus 4. So then next step is log, okay, 10 to the power of plus 4 log 10 to the power of plus 4. Then it is again log a to the power of b. This is a formula. You know already in first year only we discussed that log a to the power of 4 is equals to 4 log a, means we get 4 log 10. We get 4 log 10. Log 10 is equals to 1. Log 10 is equals to 1. Then what is we have remaining? We remaining is 4. Log 10 is equals to what? 1. Then this entire value is become the entire value of that log 0.001 divided by 0.001 square. It is become 4. Sorry. That is the value of log 0.001 divided by log 0.001 square. Then after that simple thing is um, divide this 0.0059 divided by 2. You can do it. This value again multiply with 4. The both values are again minus with 3.17. You get the answer is 3.0518 volt. The units you have to remember. That is a simplification of log things. Okay, so I hope you understand. Next problem is represent the cell in which following reaction takes place. Okay, the reaction is Mg solid plus 2Az plus 1. The values of concentration of Az plus is 0.0001 gives rise to Mg plus 2. Okay, here the concentration is given as Mg plus 2 0.001. Okay, the Az plus concentration is 0.001 m. The Mg plus 2 concentration is just 0.001. Okay, plus 2 Az. Calculate the EMF of this cell by using Nernst equation. But here the very important thing is they are not providing the inert cell. That is very important. But they're providing the standard reduction potential of Mg plus 2 and the standard reduction potential of Az. So based on these two values, means they are providing this, right? We have to look at this. This is one they're providing, and even they're providing this is 2. The two values what I marked here, that the two they are providing. Based on that, first we have to calculate the inert cell. Why? Because you know in the Nernst equation we have inert cell. Okay, in the Nernst equation we have inert cell. That's why first we have to calculate the inert cell. Inert cell we have to calculate. How to calculate the inert cell is always remember inert cell is calculated by E cathode minus inert anode. That's the formula. Inert cathode minus inert anode is the formula. Here among Mg plus 2 and among Mg plus 2 and Az plus, which is act as a cathode, that is very important. So which is act as a cathode means here the simple way to identify which is act as a cathode and which is act as a anode is look at the two values, either this value and this value. Look at the two values which is having positive value. The positive value is, I hope you are identify that the positive value is Az plus 2Az. Okay, so this is 0.80, this is a minus 2.37, minus 2.37. Okay, so that's why, among which is the cathode is Ag plus, anode is Mg plus 2. That's why first I have to represent the E naught of Ag plus 2, Ag minus E naught of Mg plus 2, Mg. Always remember, uh, you should be always minus with positive value minus negative value. One value they given positive, another value they given negative, means you can write the positive value minus, next you have to write the negative value. Okay, again you may get one doubt, sir, both are given the negative value, means what we have to do? If the both are given the negative values, means in that case you can go with lower negative minus higher negative. Lower negative means low negative value first you have to write, minus high negative value. Further problems you may get that doubt, I will clarify. huh? But here is very clearly mentioned that first there is one is a negative value, I hope you are seeing here, and there is a positive value. When both different values are given, means first you have to go with negative values minus positive values. That's why, sorry, I'm very sorry, positive values minus negative value. That's we are doing here. 0.8 minus minus 2.37, minus into minus will get the plus, both you can do the plus, will get the 3.01 volt. After that, you know that by using Nernst equation, E cell is equals to what? E naught cell minus 0.059 divided by n log mg plus 2 divided by az plus whole square. In the previous problem only I mentioned that how to write this one very clearly. E naught cell they are given 3.17 and 0.059 is fixed here. Number of electrons is equals to 2. How can you say that number of electrons is equals to 2? The mg which are converted into what? Mg plus 2. It indicates that number of electrons are 2, and log the concentration of mg plus is, they clearly mentioned, it is a 0.01. The concentration of Az plus is 0.0001 square. Simplify this. This is become 10 to the power of minus 3, and this is become 10 to the power of minus 4 square. 10 to the power of minus 4 square is 10 to the power of minus 8. This is a 10 to the power of minus 3. I will write, this is a 10 to the power of minus 3, and this is a 10 to the power of minus 8. After squaring, is a 10 to the power of minus 4. 10 to the power of minus 4 square is 10 to the power of minus 8. Then cancel this. 10 to the power of minus 5 is remaining. 10 to the power of minus 5 is going above side. It is, we have 10 to the power of plus 5. Again is a log a into b. Log a into b is nothing but what? 5 log 10. 5 log 10, and log 10 is equals to 1. You know that. Then multiply this all values this here. Then you can minus it. You will get the 3.025 volt. I hope you all understand this problem. You make it screenshot, you will get idea. There is another problem. Try to understand this problem. I hope you may get the clear idea. So this is a problem you can note down and try to understand, and do this problem is a homework. So two problems I explained. Okay, in that one problem I solved here. This is a solved problem. By using this knowledge, please do the homework of this problem. Okay. So in the next class, we are going to discuss how to calculate the equilibrium constant and inert cell, and also the relationship between the gives free energy and inert cell. So write the notes properly, do the work properly, and I will send some more problems on Nernst equation. Work that problems also. Okay. Next class we will continue the further topics. Thank you.